NetSparker, the developers of a comprehensive automated web security platform that includes web vulnerability scanning, assessment, and management. NetSparker's desktop and cloud-based security solutions employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities and provides a proof of concept. For more information, visit them on the web at securityweekly.com/NetSparker. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/securityweekly for an unlimited data trial and gain uncompromising visibility today. Welcome back, everyone, to Paul's Security Weekly. Quick announcement, our next webcast is January 15th with Cecilia Marinier. She is the RSA Program Director, Innovation and Scholars, where we will discuss the RSA Conference Sandbox, Innovation Sandbox, Launchpad, Security Scholars, a how-to seminar for innovators and entrepreneurs, and get a first look at some of the things happening at RSA, including some of the floor plans for collaboration areas and other such things. It's really interesting to me as I get some insights into RSA. You know, we go to a conference, Larry, and we're like, hey, we should like set aside some time to chat. Or you meet someone and you're like, hey, we should talk more about that. RSA is like fully embraced that. Like there's a area above where we're going to be recording where you can have a chill out space. In the app, it's almost like a dating app. So if you're interested in the same things, you can do a birds of a feather with people who are researching the same things. I was really super impressed from what I've learned so far.
Kind of progressive,
right? It's all those things that we've like, because we always get back from conferences and we're like, I got the most value out of just talking with people in HallwayCon. They've basically made HallwayCon, I don't want to say more formal because that's wrong, but easier to have a HallwayCon.
Right.
Like taking it out of the hallway into an area, and we're like, wait, is there going to be coffee in this area? And they're like, yeah.
You can do HallwayCon and you can swipe left or you can swipe right.
Yeah. In that too, and then there's a thing in the app, yeah. So all good stuff, and we'll talk about it all on the webcast. You can go to securityweekly.com, select the webcast drop-down menu, and register for that coming up. Ambuj Kumar is here with us. He is the co-founder and CEO of Fortinix and the creator of runtime encryption technology. Ambuj has built technologies and products that secure billions of devices, and I'm very, very excited to talk about how we protect our keys and our data in hybrid cloud environments. Ambuj, welcome.
Thank you. Really happy to be here.
It's nice to have you. It's interesting. One of the themes that I've been kind of harping on lately is the internet gives bad advice. And when you set out to build an app, whether locally, whether in the cloud, whether in hybrid, whether it's some pieces local, some pieces across multiple cloud providers, the problem starts to compound itself, especially when we talk about how do I protect the secrets. When you first start out building an application, maybe you don't even have a database, right? Then all of a sudden you have a database and you need database passwords. And then all of a sudden, as you get more formal and build your application, maybe you've got API keys. Now you've got user data. Now, all of a sudden, this problem of how you protect that data gets more and more complicated as your application grows. And I think, I don't know, Ambuj, if you agree with me or not, the internet has not great advice on how to solve this problem.
Yeah, I mean, that's good point. And some of this is, just a fundamental complexity of encryption, right? So in cryptography, we say that encryption decryption is easy, managing keys is hard, right?
Yes.
I can have 1 million documents or hundreds of thousands of databases distributed. I can encrypt every single entry with a single key. That is easy. How do I keep track of all those keys? How do I ensure that my right application, my right people have access to them, but not anything else? And especially in today's world where every single enterprise we have to talk to, right, like Fortune 500, they have some component that's running on their on-prem, some that's running in public cloud. And what makes it even harder is that every cloud has their own specific implementation of hardware security modules or encryption technologies, and the same techniques don't work when you come to on-prem. And these things, were developed multiple decades ago when distributed computing was not well understood, and cloud was certainly not there. So trying to retrofit those tools in today's cloud environment simply doesn't work.
I guess my next question is kind of like how you deal with application secrets, right? Which is just one component of what we're talking about. And what I've seen is that, like, there's no easy way to protect a secret, because being a hacker, right? I'm like, I just want to protect my secrets. I don't want to have to maybe use a feature inside of Docker. I don't want to use a feature inside of Kubernetes. Then you start looking at the other options. I can build a vault that can go along with my application or multiple applications. I can build that locally, right? And make that follow my application wherever I publish it. Or like Amazon has a secrets vault, and I'm sure Google and Microsoft, they also have secrets vaults. And then you just end up really confused. And you're like, how do I protect my secrets? What's your recommendation for people who are, let's just say, building a commercial application, leave other smaller apps aside? What's your recommendation for how to approach the problem of protecting secrets in your app?
Yeah, I mean, a great question, right? So first thing is that any enterprise should create an inventory of what applications, what data are meaningful for them to protect, right? And then you need to develop your encryption strategy. So you can say that, I have, for example, 3 classes of data. First one is, like generic publicly available data, so I don't need to encrypt them, right? Second one might be, personally identifiable data, PII. Third might be, maybe your account balance and things like that that are even more sensitive. And you need to have different levels of protection for the 3. And the reason for that is that different kinds of application or different types of your own employees will need access to them, right? So first you identify what you need to protect, then you put things in the bucket and you say that, this kind of data, this kind of applications need this kind of protection. So once you have done that, then you can say that, I have a class of keys that I will use to encrypt this class of data, right? And now your job is to go implement them, right? And there, that's where you need to be a little bit more careful in choosing a solution that works for you, right? So for example, what we find is if you are using simply a software-based key store, right, your keys are can actually hurt your overall security, because earlier all your API keys, etc., secrets were distributed. Now it's sitting in a vault.
Yeah, that's a great point.
That is insecure, and anybody with access to your machine can walk away with your all keys to kingdom. And so you put all that effort, right? And if you don't secure the last mile, which is where all your keys are, then you are doing a disservice to yourself, right? So how do you solve that? And so that's where some new companies like Fortanix and new cloud provider technologies, right, are coming into place. So for example, we worked with Google Cloud Platform, GCP, last month. And they are doing something really innovative working with us. So they released something called External Key Manager. And the idea behind that is that customers can bring their most sensitive data to Google platform. And all that data remains encrypted with keys that live in a customer's environment, right?
Yes, I've heard of, yes. So someone else was talking about this technology. Yeah. Yeah,
it's really incredible. And not only customers' applications can use that encrypted data, but even Google's applications. So for example, BigQuery. So you can run BigQuery on encrypted data, right? And anytime BigQuery wants to access your data, it has to talk to your little solution sitting in your environment, right, where you have full control. And guess what, right? If you say that, hey, like, why is BigQuery making calls to my production data while I thought it was just for test, right? So you can go and revoke it, right?
Yep.
Or you can say that this data should be accessible only in this particular geography. And you can set fencing around that. So you can leverage all the GCP's functionalities, and you get like same level of control over your encryption keys that you had if you are doing everything on-prem in your own environment.
Right. So sorry, Jeff, did you have a question?
Oh, I've got quite a few questions. Where to start? So I agree with what you were saying in principle, that it's certainly important to know sort of the criticality of your data. Like, Paul was saying, talking about, how do you protect data within your application? And my first thought is, well, you need to know what the data is that you need to protect.
Yeah.
So I agree with the premise of you need to sort of, perform a data classification, data inventory exercise. And maybe I mistook what you said, but I don't know anybody in the world that, other than the government, that encrypts data to a different level of cryptographic robustness. My term. People in the commercial world, they encrypt or they don't. So if you're shifting over then to a discussion of key management, which again I also agree with, the heart of the issue with cryptography is not the algorithms, and if you can thread a million computers together and quote unquote crack a cipher, which is an article I should have posted because I saw it a couple of days ago. The longest code or cipher has been broken to date, but it hasn't been broken. It's been brute force semantics. But you encrypt or you don't. Key management is the issue. But to me, it kind of boils down to more, it's not key management as much as it's sort of access control. Who can get to the keys and why? Am I misunderstanding you in some way or overstating it?
No, you are absolutely right.
Yeah,
So
I
you need
agree
to
too.
have identity-based access control, right? And you can say that like these people or these applications or these microservices have access to this set of keys, right?
Mm-hmm.
And where key management comes in play is that you can say that, hey, look, like these are very sensitive asset data, right? So what I'm going to do is basically I will rotate my keys every day. So therefore, if you are a disgruntled employee and you leave my company tomorrow, you will not have access to data that you previously had, right? So it reduces your attack surface. But encryption is just like one of many techniques, right, of cryptography. Fundamentally what you want to do is you want to reduce your attack surface. So what does it mean, right? And how does it impact? So let's say that I'm collecting your name and your SSN and your salary information, or even your genetic data, and you want to do something, right? So my goal in collecting all your information is because I have some business purpose, right? So I should, one, not even collect data that I don't need. Because if I'm doing that, I'm just burdening myself with extra sensitive data that I didn't need in the first place, right? So why do that? And it also reduces my GDPR, CCPA, all the compliance risk, right? So that's one. Then step two is basically maybe, I'm collecting your SSN, but do I really need your real SSN to do my compute? I will say no, because SSN is just, a string of numbers. It might as well be a string of letters and nothing will break. It's just an identity, right? So maybe instead of encrypting it, right, maybe I want to do a lossy transformation, right? So maybe I'll tokenize it, right? So I'll forget your SSN. Maybe I will just put a random SSN looking like number instead of that, right? Or maybe I'll put, like format preserving encryption, right? So I will have your SSN, it will get transformed. So that happens with credit card numbers, for example. So I'll take your credit card, I'll transform it to another credit card number, looking number, right? And that fake credit card number flows through all my systems, right? And finally, at the end of my application stack, somewhere my payment processor wants the real number. So at that point, it will de-tokenize it, right? So you are right that in encryption, the classification between whether it's AES 128 or 256, those are pretty pedantic, and it does not really matter. The time it will take for somebody to brute force AES 128 is much longer, and the probability that you have some glaring bug in your code where you left your firewall open, or you didn't, you are using like, some common password, those things are much higher. So that's not where you should put your effort.
But Ambuj, it's also how long I need to have that data for as
Yeah,
well, or how long I need to have that key or that access for that you can control as well.
Yeah,
right?
that's absolutely right, Paul. So one of our customers, for example, right, they took it to the next level, right? So they take lots of sensitive data, they encrypt with multiple keys, and now their data is backed up into their Oracles and SQL servers and Mongos, and it flows all around their infrastructure, right? Nobody can trace it. But the keys, they are centrally located, right? And when they want to get rid of that data, precisely your point, because they have done what they wanted to do with that data, instead of retrieving all the locations where their data is and deleting that data from there, they can simply delete the centralized key. And now your data is as good as gone. So you can simplify lots of operational headache by putting some very simple encryption techniques.
Yeah, and there's also the rotation issue too that I think is really important. And one of the things you run into in application, and we've seen, I mean, Larry and others, you've seen this in pen test, right? I get a key from someone's GitHub repository, and that key's valid, right?
Yeah.
And my concern was, well, Git is designed to preserve all of the different changes in states. So if that key, I can go delete it from one branch, right? But oh crap, it exists in 10 different, 2,500 different versions of that branch.
And depending on what type of keys they are too, now maybe GitHub does a really good job of removing and
GitHub,
stuff.
has gotten better at this.
But if it's something custom wise,
like that, now that key is out there. What I think that proper key management and vaulting technologies, what we're talking about, gives you is the ability to rotate that key. You basically invalidate that key, similar to what you're talking about in Ambuj with time, right? Now I can just change that key on a regular basis. So my attack surface in that time window where I'm vulnerable can really be shrunk, correct? Is that one of the values, right, of doing this type of key management?
That's right. I will say that, you should definitely have an architecture where nobody has access to production keys. Nobody, not the developer, not the CISO, not the CEO, nobody, right? And it is possible, right? And if you start with that mind frame, then all your API keys, all the keys and passwords that show up in your GitHub, they are designed for, either like ephemeral stage, or they can allow you to access your test data. But for production data, keys are put in some secure location, and you are authorizing use of the key by that application. Nobody gets to see the key.
Right.
And if you put like those architectures in place, then go use all my API keys, etc., that are on GitHub, and they will not yield anything useful.
Jeff? Jeff, I think you're muted.
No.
Sorry. I'm trying to preserve the bandwidth since I'm in the hotel. Sorry. I'm curious, Ambuj, do you have a strong feeling one way or the other towards public key versus traditional symmetric key cryptography?
Yeah, good question, right? So fundamentally, those things are equivalent. So you can design a system that uses public key crypto, and you can do like similar things with even symmetric keys, right? Using HMAX, etc. But they are designed for different things, right? So for example, in public infrastructure, PKI, X509 certs or padlock you see in your browser, those things are based on public key, right? And public key is also useful for authentication, etc. It's very slow though, right? So first thing people do, or like applications do using public key, is that they will kind of agree on a mutual session key or something like that. That is symmetric. Symmetric keys are faster. But like that slowness argument has been going down because now there are new curves, etc., in elliptic curve cryptography, ECC, and they are getting faster. And then there are some, feelings in crypto world that post-quantum RSA keys and factorization will be solved. So there is natural desire for people to move to either ECC, which is kind of public key crypto, or more symmetric key-based approach?
Well, so let me rephrase the question, and I'm thinking about it myself. What is the impact on the use of symmetric versus asymmetric key cryptography in terms of our overall key management discussion that we've been having?
Oh, I see. So those are, I think, equivalent, right? Because in symmetric key, you need to make sure that your symmetric keys are secured correctly. They have you have proper access control there. In public key cryptography, right? If you are storing private key, you need to make sure that like your private keys are secured properly access control, logged, etc. So it's equivalent.
Okay.
What are some of the challenges when you're developing an application? Because I've noticed a sharp contrast, right? When I secure the user's password, for example, there seems to be a really easy to implement solution for that. We were just having that discussion earlier. Larry's like, in the app that we use internally, he's like, how secure is my password? I'm like, well, we're using the standard, way to store your user password in the database, and I didn't have to really do a whole lot of design. It's just kind of built in.
Yeah, as we said, PBK DF2, right?
Yeah, and so and that was pretty straightforward, right? But then you get into the other aspects of, well, how would I encrypt other fields in the database and do the encryption inside the database for sensitive user data? How do I do that rotation of all my API keys and grant my application that it needs access to that key to go gain access to some other application to pull down some data, and that's more complicated. So what's the scale of implementation difficulty?
Yeah, great question, right? And some of the problem surfaces because we didn't have good tools, right? And so if you look for, to your point, right, passwords are something they have been brute force so many times, etc., that security guys or girls have now, proper understanding of, which has functions to use, etc. But in general, right, you don't know, or it's not widely discussed, what should you do if you are storing SSN? What should you do if you are storing, my names or emails, etc.? And so security ecosystem has not provided easy to use tools. On the other hand, developers have not been working with encryption for a long time, right? So security would be something your CISO or CIO or data center person would include towards the end of the application lifecycle. But now with whole DevSecOps, people are willing to do that, right? And I think you already hinted the proper solution, which is basically involve encryption early, right? We call it application level encryption. And the idea is that you have different fields in your application, and you take those fields, you encrypt them, you tokenize them, you decrypt them, you detokenize them, right? So you can do all those operations. And how do you do that, right? How do I know that your application is authorized for that encryption or decryption call? That is very simple. Just as a user, when you log into your system, you provide your password or you use your SSO, and then you get access to certain applications. Now, similarly, a microservice or an application that wants to do this encryption, decryption of different data fields, it needs to authenticate itself to a centralized key management system, for example. Now, the question is, how do you bootstrap the process, right? How do I know that this is the application that is authorized or this is the application that is not authorized? And that's where Kubernetes, etc., make life a lot easier, right? So there are multiple frameworks now being developed. Google Istio is a good one. And what they try to do is they will attach an identity to your particular instance, right? And the goal is to make that identity unforgeable as much as possible. And we are still a few steps away from making it truly unforgeable. But there is an identity attached to your instance. Your instance treats that as API key or secret key or user's password. It presents that identity to a centralized key management and says that, hey, I need access to key 9. And the KMS says, oh yeah, this application should have access to key 9. It returns that key 9. And then in the application, you make a simple JCE call if you are using Java or you use like crypto libraries, and you do encryption and decryption at the field level.
So do you need to further protect the keys once they get into the application in like terms of OAuth, right? Because in OAuth you get two keys, right? Because you can refresh your key on the fly. And I've done some work with that, but I have to admit I don't fully understand like how I should be protecting those OAuth keys, right?
No, that's right. That's right. And you are just barely scratching surface of something that is very, very important and very, very fundamental, right? So you are right that once the application gets the key, how does it secure, right? So I'll give two answers. One is that you may not always need to secure it. The goal of encryption or any security is to reduce your business risk, right? So earlier, if I was a hacker and I simply, found an open IP address and logged into your network and found some asset that was not decrypted and I walked away with that is very risky. Now, at least I have to wait for your application to go fetch that key,
right?
And then I can steal that, right? So you just made it harder, right? So it's not useless even if you are not securing the key as it's being used. But your second point, which is basically, let's say that I have really sensitive data, right? And my application needs to fetch a key and it decrypts the data. Key is in the application memory, decrypted data is in application memory. How do I secure it? And that's the problem that Photonix, I founded Photonix to solve, and we call it runtime encryption. And turns out, Paul, that is very hard problem to solve.
Yeah, well, yeah, because I've looked at that too. Because again, the hacker mindset. I'm like, but the application has access to, like you said, the keys and the data. I'm like, so really, does it just come down? I have to harden my application at that point, right? Not necessarily how it's built and deployed, which is typically where the keys leak out. I've got to harden my application so there's no command injection. There's no way for an external or even internal user with credentials to be able to grab that information, right?
Yeah, but it does not stop there. That's the sad part, right? So even if you harden all the your application, right, and you take every single precaution, best practice, and everything, right? Guess what? There is a bad application running on the same machine as you.
Yeah, exactly.
And there is a simple buffer overflow, and using that, you exploited some vulnerability in operating system.
Someone else's container gets popped and gets root access to everything. Yeah,
exactly. Or even not even at the container level, right? I might have some 0-day vulnerability in the underlying, hypervisor or operating system.
Yep.
Or I can have your root password get compromised, right? And using that, I can install a driver that's funny. So this is what I find very fascinating about security. Right now, in order for your application to do its job right, you need to make sure your application is built correctly. And also all the surrounding environment, right? Like infrastructure, machine, operating system, Kubernetes, etc. Everything is fine.
My software supply chain. Oh God, do we dare go there, right?
It's a never-ending problem, right?
Yeah. Drink.
But there is hope. There is hope, and hope is basically using hardware enclaves. And without going too much into technical details, hardware enclaves are an isolated region of execution space provided by modern CPUs, where essentially it's like unikernel. Your application comes and executes there, and it's isolated from every other software on your system. So not your operating system, not your hypervisor, not the your neighbor's container, not somebody else's application in the same container space. So your application is given a execution space that is completely private to anyone else. So if you did your job right, which is basically you don't have any buffer overflow and things like that, or you are not taking my data and sending to badguy.com, then you can be like reasonably sure that keys and data, even if your application is running, they're even protected. So Intel provides that. They call it software guard extension. AMD provides them. It's called SCV. ARM provides it. It's called Trust Zone. RISC-V has something called Sanctum. So those are like some of the new advancements in CPU technologies.
But does that protect against if I've included a backdoor library or software component in my application?
No, that
Right.
cannot protect.
Yeah.
And funny thing is that nothing can protect that, right? Because it goes into a whole halting problem, right? So if somebody gives you a software and it says that, hey, I'll protect you from vulnerabilities in your software, right? Then it's direct violation of halting problem. So best we can do today, and in future, unless our understanding of laws of physics change drastically, to review application code, right? And you can do manually, you can do it automatic way.
Right. Well, we have to build the trust of what's going into our application, right? And there may be cryptography we might use to validate that trust, right? But that's right. You have to include that in your application.
Yeah, you have to assume that this is the code written by my trusted employees,
yep.
and it does not have any backdoor. And then you can, then you can create signatures on them, and then you can encrypt the application, and you can go drop in some enclave, make sure that, oh, this is the application, it has not been modified in between, right?
Right.
And then you can have it run. But the trust needs to come from you.
Yeah.
So I have a question.
Go ahead, Lee.
Yeah.
So we've talked about using the secure hardware enclave to protect sensitive information. We've talked about on and off-prem key storage management, and we've talked about insecure library in your code. Do you have a reference somewhere that says for this scenario of protecting sensitive information, use this kind of technique, or is there such a reference because these are all different techniques with different values and different strengths and weaknesses?
It's a good question. It's one that we struggle with all the time, both internally and talking with others building applications, quite frankly.
Yeah. So, roughly I divide security in two spaces. One I call application security, and this is, loose definitions, right? Application security is trying to make you write a good application. An application, free of known vulnerabilities. It does not have buffer overflow kind of problems. It does not have backdoor. It does not take your data and send to badguy.com. And those things are, really well understood. But they are far from being solved. They will never be solved because of the halting problem I alluded to earlier, right? So there are lots of, scanners and vulnerability management companies that do that. But at the end of application security, you have an application that you trust, and you are just interested in running that application. But guess what? Your application needs more to run, right? It needs a machine, it needs an operating system, it needs external libraries, it needs to talk to outside world, it needs TLS, all those things.
It needs at least 12 AWS services to run, right? And they all have to trust each other in some way, right?
That's right. And that's where infrastructure security comes in, right? And the need for infrastructure security is, again, so that you have a sane infrastructure for your known good applications to run, right? And what we have done so far is we have invested lots of money and energy in network-based approaches to solve infrastructure security, right? So think of firewalls and IPS and IDS, all those things. And they're trying to do just one thing, which is basically they will make it harder for a bad network packet or bad network user to get into your environment. But in distributed world, it gets harder and harder, right? Because you are in multiple VPCs, multiple networks, and just
what is the network today when we're deploying a modern application across all these microservices, right?
Yeah, it will be probably year-long project just to enumerate that, and by the time you enumerate it, it would have changed. So it doesn't work, right? And so the way to do security right, in my mind, and again, this is this could be a polarizing view, is to decouple security from infrastructure. So my view is that, hey guys, just realize you will never be able to secure your infrastructure. Hey, you don't even own your infrastructure; it's shared infrastructure, right? And if you have that humility, then you can take the next step, which is basically, if you assume your infrastructure is compromised, then what, right? Then what you can do? And that's where some of the techniques from cryptography come into play, right? So if you are using secure enclaves, right, then you don't need secure infrastructure to work. So I will say that for application security, use known AppSec tools. For rest of the world, which is basically once you know you have a good application, you are interested in shielding that application from outside, then you use something secure enclaves where you are not relying on outside world to secure you. It's built in.
Yeah, that's interesting. We've talked about this, maybe not in this perspective, right? That the network security that we've traditionally done is really not applicable today, right? Because it's that external view of like, can this machine talk to this machine? And when we're talking about applications today, we're like, well, hold on, what's the machine?
And where's the machine? And where's the application?
There's a machine somewhere, but now it's so far abstracted from our application that doing security or trying to do security on that machine in that network is just, it's not going to get us anywhere. Did I summarize that correctly, Ambuj?
Yes and no. I agree with what you're saying, Paul, on one level, but from how do you secure it perspective, yes. But in terms of the principles of what you need to protect, I don't think the principles of security change. It's just how you do it is a whole lot different these days, given
I agree.
The way we do things.
How you maintain and implement that trust is different, but the trust is still implicit in this discussion, right? And that principle of trust.
So, Paul, I will say that containers have done much more to educate people on fallacy of network security than anything else.
Yeah, agree.
To understand it. Because I was talking to one customer, right, and they were like, "Hey, our containers live for 4 hours, and then they go away, and there's a new identity, new thing. So how do I put how do I know their identity? How can I put network controls in place?" I was like, yeah, welcome to reality.
You say that, and I agree, but does container security do it better?
Yeah.
Not can it do it better, but does it do it better?
I think, that's right.
I think the opportunity, Ambuj, right, to do it better is there.
Yeah, that's right.
Not always implemented correctly, but that's always going to be the case.
Devil's in the details.
Yeah.
Yeah, and it forces people to move away from traditional approach where they were always thinking about perimeter and group of machines, things like that, right? Because now suddenly, your network, your security profile is based on container identity, right? So it just starts a conversation, and you realize that maybe network-based identity is not useful. Network-based controls are not useful. Maybe I need to look into container at the application level. Maybe I should have identity to every container. Maybe I should use encryption. Maybe I should tag my machines. And even if the same application is running in Germany, that might have very different risk profile or access control than an application that is running in rest of Europe, right? Because German laws are very restrict compared to other EU countries, right? So there are lots of things, and since containers are forcing, modernization of infrastructure, they're also forcing modernization of security, and it's a great place to reevaluate some of the security techniques that people have taken for granted and has not worked.
And I think some of the resources that you have provided us, Ambuj, talk about basically how you bring that trust model along with you to whatever cloud provider that you're using, right? Because as I look at the modern application landscape, I can totally see some stuff I'm going to keep on-premise, and then I really like the service from Amazon, and then for this part of my application, I really like this thing from Google. But when you start going to that model, you still need to maintain your own trust between all the different pieces of your application, correct? Is that kind of where some of your resources are focused?
Yeah, exactly right, Paul. Exactly right. So, if you look at modern enterprises, right, and they're running their applications in cloud, what does cloud provide them, right? Cloud provides them CPU cycles, right? It provides them storage, network connectivity, things like that. And those are tools, right? Cloud might also have some built-in SaaS services, right? 24 of them, and cloud providers are forcing them, right, in some ways, to their customers, etc. But the business logic or application intelligence, that comes from the business, because enterprises, they have a particular goal in mind. They have their custom application that provides some functionality, so they bring that in. They also need to bring in the security with themselves, right? Because only they know the risk profile of their application. Only they know what kind of data they are churning, right? What kind of data they're processing. So if they involve security principles right, they will start to do it sooner as they are building their application. And by definition, when they are building their application and putting their container together, for example, right, things they can do, they will not depend on the underlying cloud technologies. So as an implication of that is that they need to think about their security controls, make them built in their application, so to say. And if they do that, then like good things happen, right? Because now suddenly you can take your application anywhere and it will follow the same security policies, right?
Which actually has a benefit to the. Here's where security has a benefit to the business, right? Gives you more options. Yeah,
exactly.
So
I love that.
I had what I hope is not a hard question. We talked about all the different security options and models, and a little bit about what people are considering. But what do you see people not asking or taking for granted, particularly as they're moving into the cloud space? What are some key things that people should focus on?
So I mean, yeah, good question, right? I will say that security has always been on defensive, right? So people have viewed that, if I do this, I suffer through so much pain, then, my business will not suffer later. And today's investment for security is less than the potential loss in future. So therefore, I should buy security tools. I'm like personally very, very excited that security can actually change that equation, right? It's again, early days. But using cryptography and security, you can do some amazing things that were previously simply not possible. And people are not considering that as much as they should or they would, because it's just new, right? So I'll give you one example, right? So there is a cancer researcher, for example, right? And they are processing sensitive genomic data to harvest some insight on what causes cancer, things like that, right? Now, if they come to me and say that, hey, I'm interested in your lifestyle. What do you eat? What is your race, your blood sample, your DNA, the whole 9 yards, right? And in return, we will build this model that will be, useful for cancer screening, right? Do you want to participate? Being a security and privacy conscious person, I would start to ask them, hey, what are the chances my data will get misused, right? Things like that. We live in a dangerous world, right? As dangerous connected world. On the other hand, right, if that same cancer researcher offered me the same benefits, right, and they said that, look, even if my machine gets compromised, even if once I collect your data, and even when I want to sell to some advertiser, I will not be able to do that, right? So it's not that I won't, I will not, I cannot, because cryptography will make it impossible, right? Then heck, I will give my data right now. And so would everybody else. So society can really innovate much faster pace. There are similar data sharing things that we don't do because we simply don't trust what the other side will do with our data. And I'm really excited about that because I think we are barely scratching what is possible if you really believe that you had access to secure, safe, private computing.
No, it's a great point. Ambuj, thank you so much for appearing on Paul Security Weekly. It was fantastic chatting with you. There are more resources in the show notes for this episode on our wiki.securityweekly.com. Ambuj, thank you so much.
Thanks, Paul, for having me. Cheers.
And with that, we'll take a short break, come back with the security news for this week. Stay tuned.